Hello, folks. Welcome. Thank you very much, everyone, for attending. We had intended for this to be an in-person. We actually had intended for Hugo to speak to us last month in person. He got sick the day of and very wisely bowed out, and we filled it in with Kirill Mueller. Very happened to be in New York at that time and was able to speak for us. Very lucky chain of events. So then we intended for this meetup to be in person this month with Hugo, but our venue couldn't host us this month. So we're here virtually. And when I say in person, I mean both virtually and in person. We're always going to do it going forward in the future, both virtual and in person, so everyone around the world can join us. We are hoping to be doing that this month, but we didn't have a venue. It actually, in these, I don't want to say post-COVID times, these during COVID times, whatever it is, the COVID transitional times, whatever you want to call these times, it's hard to find spaces to hold us. So if you, your company, your organization would like to host the meetup on an ongoing basis or even occasionally, send me a message. You know how to find me on Twitter, on LinkedIn, on meetup.com, on the NYHackR Slack, my email at jaredlander.com, at landeranalytics.com. Any way possible, find a way to get in touch with me. Say hi, tell us you would like to host the meetup. I would be very, very excited about that. All right. So thank you everyone for being here virtually. And again, hopefully at some point soon, both in person and virtual, as soon as we can find more venues to host us. In the past, we had a number of different places we'd rotate between. So please, let's get that going again. The first thing I like to do when it's in person, which we had 2 in-person and virtual meetups the past 2 months, I was very excited. We could ask this, I ask who's hiring. Since I know we can't all stand up and say you're hiring, please go to the NYHackR Slack, which you can find at nyhackr.org, and go to the job postings channel and post your job there. Let people know that you're looking to hire, and people who want to get hired, go there and find a job. If you want to get hired by me, go to my website. Actually, all the jobs aren't posted, but we're looking for an account executive and a Linux admin. Both of those are posted, and a data scientist. That's not posted, but just apply for the Shiny Dev. Close enough. We'll get it posted eventually. So if you want to learn more about the jobs I offer, contact me or go to landeranalytics.com/careers. And again, please go to jobs, the jobs channel on NYHackR and post it. Another thing we are missing out on by not having an in-person component is fabulous New York City pizza. So I got my pizza today from Vito's. See, I got a square slice and I got a round slice. There's good cheese lock, but it's been sitting for a little bit, so of course it's gonna be good. Here too, good cheese lock. See, this was made in a pan, and this was made right on the gas stack oven. So please let us know in the chat where you got your pizza from, or whatever other food you choose to eat today. Let me know where you got it from. Let us know what it is. Tell us all about your meals, what this fun stuff you're doing. I love to make, people who know and come to the meetup know that food is a big part of the meetup, at least pizza is. So let me know, join in the chat. Speaking of chat, either use the Zoom chat right here or in the NYHackR Slack, go to the monthly meetup channel. Either place is great to chat with us, so let us know. This past week or 2 ago, we posted the videos from the New York R conference. We had the New York R conference back in June 9th and 10th. The videos are up live. You can find them at rstats.ai. In fact, if you go to rstats.ai, you can find videos from all the New York R conferences and all the DCR and RGov conferences up there. So if you want to check these out, most of them are 20 minutes. Occasional few special ones are 40. Nice, quick, easy. Go check them out, rstats.ai, to find all these great videos. And we are very excited. We haven't announced this yet, but we're at the meetup now, so I got to tell you some things early. December 1st through 2nd, actually November 30th through December 2nd, because we have workshops. The R in Government Conference is returning live, both in person and virtual, at Georgetown. We are very excited for this. We're going to make an official announcement soon. This is meant for anyone who's involved with R or data science, because remember, like this meetup, the conference, even though it has R in the name, is R and Friends. We've always been about open source data, whether that is R, Python, SQL, Julia, Go, Stan, C++, or just the math behind it, or just the theory, or just the practice. It's R and Friends. So this, for anyone who's using R or data science in the practice of government, that means federal, local, state, means international. You could be working for government from another country or a province, or in public sector. If you work in the healthcare sector or education, this conference is for all of you. If you'd like to give a talk, we are accepting submissions for talks. Message me, tell me your idea. If the topic's good, then we'll ask for an abstract. And if it passes the litmus test, I guess, for lack of a better word, then you get to speak. It's a very, very friendly conference. Any of you have been to any of the conferences we put on, you know what it's like. So December 1st through 2nd for the conference and November 30th for the workshops. Again, both in person at Georgetown and virtual on Hopin. Speaking of conferences, there is in October 6th through 7th, there is a Shiny in Production conference in Newcastle, UK. That's put on by friends of ours, Jumping Rivers. We're fans of theirs. They run a similar company to the run that we run, and we're friendly with them. And I'd like everyone to say, if you happen to be in Newcastle, go to the Shiny in Production. So, before we start the meetup, first, please introduce yourselves. Let us know who you are, where you're coming from. And if you have questions that you want to ask Hugo, please post it either here in the Zoom chat or in the monthly meetup chat I mentioned before in our Slack. So go there, tell us what you're eating. If you have questions at the end of the chat of the meetup, I will take all the questions and ask Hugo. The harder the questions, the better. I want him to be stumped by the end of this. We want to make sure that he doesn't know what's going on here. No, but seriously, ask
too hard to stump me, I don't think.
All right, quick, everyone, come up with your hardest math questions. I want him to prove Fermat's last theorem here. All right, that's the goal. So that wasn't nerdy enough for everybody. I hope we can get nerdier. Everyone, please give a warm virtual welcome to Hugo. Thank you very much for being here, Hugo.
Thanks, everyone. And I have to apologize, Jared. I actually don't have any pizza to eat while speaking. But in my defense, I had a bialy for breakfast from Cossar's.
Oh, from Cossar. Then that's good enough. You got a Cossar's bialy. That's legit, man. We have an awesome speaker here who used to live in New York and I first met him at the conference, the R conference, I believe, not the meetup, but the conference.
The first R conference, the
very first R conference. And Hugo was a mainstay in the New York community until he went back down under. He's been living there. He's worked many different companies. You probably heard him from his podcast. He's hosted a number of very successful podcasts. And he's awesome. That's how I like to introduce people.
That is the best introduction I could never have given myself. So I appreciate it very much. And Jared's right. Actually, I started coming to this meetup when I lived in New Haven, Connecticut, which wasn't for me. But when I started coming to the meetup in the city, I was still working in academic research and trying to figure out how to get into industry in a variety of ways. And this meetup, among a few other places, was so important for me to meet people in the city, to feel part of a community, and it still feels like home. So I just want to give a huge shout out to Jared, everyone who works with Jared, the meetup and the conferences and all the great work you do. And it's so great to be back.
Thank you very much, Hugo. That's really nice. Yeah. It's good to have you, and I'm excited for this.
Yeah, and so a bit more background about me. I've worked in data science education, ML education, tool building, for a variety of startups and open source frameworks and packages. Kind of my origin story. I worked in basic research in science, and I saw some of the best scientists of my generation. I seriously saw some of the best scientists of many generations not being able to do what they needed to do because of a serious lack of tooling and education around tooling. And I enjoyed doing the science as much as I enjoyed all the developer relations, all the advocacy, all the tool building. I do, but it struck me as the work that I could do in education and developer relations was a lot more impactful for me. And that's actually why I've started working in thinking more about machine learning infrastructure. I think this is one of the most, let me say, fragmented aspects of the data science space we all work in. So trying to make headway there is something I'm really interested in. So without further ado, that's just a bit about me. I'll share my screen. I also do want to ask a question. We're going to be talking about MLOps and DevOps and why data makes it different, and why this kind of field of MLOps has emerged, quote unquote. Hey, Max, great to see you, man. Very interested in your thoughts on this as well. I would, because we're really talking about operationalizing and productionizing machine learning models, I'd love to know what that actually means to you. If you could put in the chat, and this is not a trick question. I think the idea of productionizing or operationalizing a model it isn't binary, right? It's not a yes or no. I don't even think it's necessarily a spectrum. I think it's this, huge multi-dimensional space that means different things to different people. So if you could give a shout out or put in the Slack chat or the Zoom chat, what operationalizing or production means to you, that would just help me kind of give me some sort of compass and a yardstick, so to speak, for who's here. So I just want to give a brief origin story for operationalizing machine learning. I work on software called Metaflow, which was born out of Netflix. So I want to give a brief origin story of what happened with Metaflow at Netflix, but this is relatively generalizable. So in the beginning, there wasn't light, there were just recommendations. And of course, there's lots of other things that machine learning, and we'll even talk about what machine learning actually means, can do. And then it was suddenly like, oh, we've got some natural language stuff that may help us with certain things. There's computer vision, of course, when thinking about video data. We're customers, and it's a subscription model. We have customers and there's a subscription model. So we need to think about predicting churn, and the list goes on, right? So over time at Netflix, a diverse set of use cases for machine learning started popping up, as we're seeing in a lot of industries, okay? So as tool builders and working in education, I think it's really important a lot of it is pattern recognition, right? So thinking about what is common across all the different ML projects, right? So what was happening at Netflix and a lot of other places, as we know, all projects need data, whether that's tables, text, image data, looking at metrics, these types of things. This is common across all projects. Then a lot of projects need to execute compute-intensive algorithms at scale. So suddenly we may need some sort of cloud resources or something along those lines, right? Projects, data science workflows, in the end, tend to consist of multiple steps that need to be executed, right? So maybe we need to orchestrate them in some way when we reach this part of the conversation. On top of this, all projects are developed iteratively through multiple versions. So suddenly, we're not only talking about versioning code, maybe we're talking about versioning models or versioning data, versioning software, right? So this becomes a concern. And this may not be a concern for absolutely everybody, but it's a big enough pattern that it's something we need to reckon with as a field and a discipline, right? All projects, we can almost definitively say this, leverage third-party libraries, including a lot of open source technologies as well, right? So then the question really becomes, can we address all of these concerns in a single coherent framework? And I think the answer is we can, but we want it to be interoperable with a lot of other existing frameworks. And I think that's something that we've seen in the space increasingly, is as opposed to having like all-in-one platforms which serve the needs of a data scientist, which I actually don't think in the short to medium term is possible at all. We're seeing collections of interoperable open source frameworks and also commercial offerings connect and form these pipelines, so to speak. So this is important, but this is from kind of the view of a toolmaker in a lot of ways. I kind of spoke to some of the data scientist concerns, and I've already got a few responses to, this is great, to what productionizing machine learning means. Fred has said automating complex processes, great. Marcus said operationalizing means processes documented, repeatable procedures. Repeatable is a fantastic term when we're thinking about operationalizing or productionizing. Derek has said provide scalable data infrastructure to interact with end user. So we have infrastructure, we have data infrastructure, we have something be scalable, we have repeatable, we have automation, right? These, I mean, I've just said 5, maybe these are like 4 dimensions if we project down slightly. Jared has said check Slack too, so I'll definitely do that. Chintan has said operationalizing machine learning means making inferences with a trained model in a way that's fast, reliable, and scalable, depending on the use case. Brilliant. Software engineering best practices play into all of these things. It's a question of what we should adopt as data professionals from software engineering best practices. I think, of course, version control, refactoring, testing, unit testing, data testing. It's not clear to me whether, I don't want to start flame wars. It's not clear to me whether CI/CD is the best paradigm and mental model for what we want to do when operationalizing machine learning models. So it's a good question, what we want to adopt from software and engineering. Awesome. So we have a lot more coming in, and I think we can definitely circle back to them. But what I wanted to do, given all of this, is kind of talk briefly about what a data scientist does when they're going from prototype to production, okay? So we want to take something from prototype and productionize it, whatever that may mean, right? And what crops up there. So a lot of the time we start exploring in notebooks, okay? Now, when I want to deploy code or something along those lines, I know there are a subset of people who like doing this wonderfully with notebooks. My preference, and a lot of people's, I mean, I'm already starting another flame war clearly, is to then convert my exploratory data analysis and first models into some form of script with some form of workflow, right? And so this may be doing some basic orchestration, writing a DAG, something along these lines, okay? Then you want to start thinking about versioning, as we talked about before. If you're, let's say you've got 3 models that you're trying to train in parallel to see which performs best, and you're updating them according to different data sets or whatever it may be, we want to start versioning these things, and so that we're able to reference them later on, right? Then we might want to scale vertically. We may want to use one really large compute instance to see how our model works on as much data as possible. If our data set gets big enough, or we want to do a lot of parallel training, maybe we want to scale horizontally to leverage clusters, right? We may want to access data super quickly. And this is actually a huge challenge, right? Because when we're prototyping on a laptop, maybe someone sent me a CSV or something, right? But that, when we're doing kind of this graduating approach to machine learning, step by step, you know, we may not have a CSV anymore. Maybe we're reading from Parquet files on S3, or maybe we're using, you know, Athena to query Snowflake or whatever it is, right? So this is another kind of small step in the direction of productionizing, which may not, you know, in itself be productionizing, but it's one dimension of the types of things we need to talk about. We may want to schedule execution. Okay, and this, serving an endpoint or schedule execution, I think, is one of the things that people think is definitive of productionizing or operationalizing. But some of the highest impact machine learning models I've ever seen internally at companies are models that have been delivered via PowerPoint presentations. Think about a big tech company that an executive needs to make a decision on what type of billboards they put on which highways in which states, right? This costs a lot of money, right? For big tech companies. This is not automated, but they have all types of machine learning models that play into this decision-making process, which significantly impact ROI. And this is not scheduled execution, right? This is something that's, you know, hand-delivered and spoken about. It's also not necessarily automated on either side. The execution isn't automated and the generation isn't automated, right? And yet, I think if you say this isn't productionized because we haven't got an endpoint, look, maybe I'll give you that, but it defeats the point to say it isn't productionized, I suppose, is my point. It's definitively operationalized. And that's really what we're talking about here, how to get machine learning to impact decision-making, right? I'm going to stop on freeze dependencies. I don't want to say anything more about this, as you know, I've been in dependency purgatory, if not hell, for several months. But the struggle is real, and particularly when moving between local compute, cloud compute, making sure that you have the same dependencies moving back and forth is incredibly important when thinking about operationalizing and productionizing machine learning models. Okay. One final point, of course, even after you do all of this, maybe you want to A/B test your models, do experiments in parallel, and then promote a challenger model to production if it beats someone in production, right? So these are all concerns that happen when thinking about moving towards production, each of which by itself may not be productionized per se, but you put a few together in order to productionize. And really, that's all to say, once again, that productionization or operationalizing isn't just one thing. It's a whole suite of tools and techniques with the goal of either having an action automated or helping a decision maker make a business decision. So just to be clear, everything I've just told you will fail all the time. And the reason I want to make that clear is because I want to make it incredibly clear that the path to production is incremental and iterative. So you either are or will be moving between prototype and production constantly. And part of my life mission for scientists is to make sure that this loop is as tight as possible. That's one of the reasons I'm excited to work on these problems. One of the reasons I'm excited to work at Metaflow or with Metaflow, for Metaflow, as Metaflow, is because I believe there's a huge opportunity to tighten this loop. And I think Metaflow, before I joined, did a relatively good job, and it's definitely seems to be getting better. So kind of to wrap up this section, I'm just going to move the camera to the video bar. What I really want to say is that production readiness is a spectrum. More than that, it's a multi-dimensional space. And we need to be supporting projects at all phases of their life cycle. So if there's a project that's promising, we want to then be able to scale it to all the data that the data scientist or machine learner needs. If predictions feed here into a decision support system, we want humans to be able to error correct it if needed. This actually, I'd almost hesitate to reintroduce this term into common lexicon, but this is a question of cybernetics, right? Of how, the pilot and the machine work together, and how we do our best work while machines do their best work, okay? And so we have a number of other use cases here, but I think I've buried this point, that it definitely is a multi-dimensional space. So why am I talking about all of this, right? When we're here to talk about MLOps, what even is MLOps, right? Why does machine learning need special treatment? And it's a good question, and that's why I'm asking it. Can't we just fold the ML needs of software into existing DevOps best practices, right? And I think the answer is no. And that's part of my thesis of why this term MLOps. Once again, it's a macro trend of tools and practices and conversations and LARPing and marketing that has brought this to the front. But like big data, like data science, like all of these terms, I think there is an underlying current that is worth looking at once we get rid of all the marketing BS. And that's kind of part of what I intend to do this evening. So first I'll answer these questions, then I'll start to talk about what a modern technology stack for streamlined ML processes looks like. And then we'll chat briefly about how you can start applying the stack in practice today. So why does machine learning need, I love this horrible figure. So yeah, why does ML, and sorry, just to be clear, by machine learning, I'm not even talking about machine learning. Sorry, if anybody thought I would be. I'm half joking. What I mean by that is we use the term machine learning for a lot of different things. When I talk about machine learning powered applications or machine learning powered software, it could be a statistical inference model. It doesn't need to be a machine learning model. It could be just software that's powered by data as well. I think more generally, what we're all talking about here when thinking about MLOps is not just the operations and the stack for machine learning, but it is for how we think about and build software that's powered by data. Now, if you want to limit that to fit and predict and endpoints, I'm chill with that. But I want to make clear that I think kind of a broader worldview is potentially useful here. Happy to have that challenged. Actually excited to have that challenged. Wish I had a slice of pizza for any coming challenges, but so why does ML require a different conversation? Okay, so let's just think about the job of a non-machine learning software engineer. Okay, so on average, I know there are edge cases and outliers, and That's the problem with social media. No, I'm kidding. But writing traditional software on average deals with well-defined, narrowly scoped inputs, which the engineer can exhaustively and cleanly model in the code. Whether that happens or not all the time, I'll leave that up to you. But in effect, what happens is the engineer designs and builds the world wherein the software operates, okay? In distinct and direct contrast to this, a defining feature of machine learning powered applications is that they're actually exposed constantly and directly to a large amount of messy real world data, which is just too complicated and or complex to be modeled by hand, okay? So what this means is that machine learning applications are actually fundamentally different from traditional software. But that's relatively abstract. What I want to do now is think about what the implications are as to how such software should be developed and by whom, okay? So data changes everything because machine learning applications, as I've said, are directly exposed to the constantly changing real world through data, okay? Whereas traditional software operates in a simplified, static, abstract world, which is directly constructed by the developer. What's the implication of this? Or what else do we have involved? Machine learning software needs to be developed through cycles of experimentation. This is due to, I've been saying due, but it's due because we're in New York. Due to the constant exposure to data, we don't learn the behavior of machine learning apps through logical reasoning alone, but through empirical observation, okay? So we have this defining characteristic of experimentation. So what happens then? Then what happens is that the skill set and the background of people building the applications gets realigned, okay? So while it is still effective to express applications in code, the emphasis actually shifts. And I think that's probably why a lot of us are here today. The emphasis shifts to data and experimentation. That's more akin to empirical science rather than traditional software engineering, okay? Now, I want to make clear that this approach isn't new. And as many of us will recognize, there's a decades-long tradition of data-centric programming, okay? So we have RStudio, of course, MATLAB, Jupyter Notebooks, Excel, and I think one of the OGs was actually Mathematica notebooks, right? Which essentially, this is a whole suite of data-centric IDEs that people have been using since at least the 80s and came to the fore in the past couple of decades, right? Now, why aren't these necessarily yet useful for operationalizing or productionizing machine learning models, whereas they're great for prototyping, right? One reason is because they're relatively insular, but I think there are probably 3 things or 4 things clearly that we need to talk about. A lot of the time, what we're doing now, or what we're talking about, the scale of operations are actually is 2 orders of magnitude larger than in early data-centric environments. Not only is the data larger, but models, for example, deep learning models, are much larger than before, okay? Second thing that changes, modern machine learning applications need to be carefully orchestrated. Got a huge increase in the complexity of such applications, which can require interconnected steps. Essentially, we need better software paradigms such as DAGs, directed acyclic graphs, right? Which perhaps weren't necessary when we were using Mathematica notebooks back in the day. This isn't to say that the data-centric paradigm and literate programming can't be extremely useful here. I want to make that very clear. But we do need a suite of other tools. And this is kind of why MLOps has arisen, in our opinion, anyway. As I've mentioned briefly, we need robust versioning for data, for models, for code, and preferably even the internal state of applications, right? So I want you to be thinking like Git on steroids to answer questions that will arise, such as what changed? Why did something break? How do 2 iterations compare? Who did what and when? Okay, so we want to be taking snapshots all throughout, right? Now, the 4th incredibly important reason is that the applications need to be integrated into surrounding business systems. So ideas can be tested and validated in the real world in a controlled manner, okay? So in these two lists, two important trends collide, okay? So on the one case, in the one case, we have the long tradition of data-centric programming. And on the other, we're facing the needs of modern large-scale business applications, right? And I think either paradigm is insufficient for what we need to do. I mean, I wouldn't advise anyone to build a modern machine learning application in Excel. I mean, maybe you've tried and maybe it works, but I'd suggest that's an edge case. And in the same breath, it'd be ridiculous to claim that a data-intensive application is similar to a run-of-the-mill microservice, which can be built with GitHub, Docker, Kubernetes, these types of things, right? So in this modern production infrastructure for data science is where kind of this MLOps space has arisen. And I think whether we use the term MLOps or not, I honestly don't care. But what we really need to figure out is what is happening in this space when we have the collision of all of these different trends and where to move from here, okay? So essentially what we need is a new path that allows all the results of data-centric programming models and data science applications to be deployed on modern infrastructure. I'm doing gestures like this to gesture. Looks like I'm, about to kickbox with Max Kuhn or something. But to gesture which side of the triangle I'm going up. But if I'm mirror imaged in your display, I mean, just flip me back, okay? So, having ascertained kind of why ML needs special treatment, I mean, a good question to ask, which is why I ask it. Now, the reason I ask it is because people have asked me it so many times as well, is what does a modern technology stack for streamlined ML processes look like? And I'm not going to go into all the different, I mean, there are 100 different tools for each layer in this stack, right? And that, like, I meant to exaggerate, but I don't even think I did. Okay, so the question is, what does the stack even look like, right? And as we saw before, when you're going from prototype to production, you're suddenly, interacting with larger data, trying to get more compute, having to orchestrate things. You've got versioning, you've got software architecture, you've got model ops, feature engineering, model development up the top, right? And the question is, should anybody ever be accountable or responsible for this entire stack? And I personally, like, maybe there are some legends out there who can do it, like 10x whatevers. But I definitively think no. And most scientists I know don't want to focus on everything here. Arguably, the pattern we've seen is that most data scientists want to build models, right? And work with features, and have the data that's ready to explore it, and all of these types of things, and figure out what's happening in the data, right? The reason data is at the bottom here, of course, is because we're talking about data infrastructure, not necessarily the model that the data science constantly interacts with. But essentially, what we've seen time and time again is that we require a huge amount of infrastructure for what happens at the bottom. And data scientists really want to be able to focus on the top. So what I'm really interested in is building tools and helping people use tools that allow tens of millions of scientists to focus on the models and the features and the data, while having access to all the infrastructural layers at the bottom. One example that I might show you later, I might not actually, is when we look at some Metaflow code at the end as an example. When you prototype code workflows in Metaflow, you do it all locally. If you have a step that is becoming computationally intensive, such as training on a large data set, whatever it may be, you can, at that step, use an @Kubernetes decorator or @batch, AWS batch, in order, or @GPU to allocate that step, infrastructural cloud resources for that step, once it's set up, right? But the whole point of that paradigm is so that once your machine learning engineer has set up the compute for you to use as a data scientist, you don't need to change any code except for one line. And it may just be uncommenting something that's there actually. And that's one way that I really think will help with this iteration cycle between prototype and production, making the ability to send things to the cloud and back with the same dependencies, with the same data or larger data, whatever it is, specifying it in my case, in idiomatic Python, but of course, in whatever language of choice, without having to delve deep into like nested YAMLs or, you know, all types of crazy configuration files. So I think one more story that we've talked about going from prototype to production, but thinking about how a data scientist may interact with all these layers, right? So we have our data scientists here, and they're using their laptop to access a cloud workstation where they've got VS Code or Jupyter or whatever it may be. Okay, so they need to access data, which locally would have been a CSV. But now, as we're trying to productionize things or operationalize things, we're actually going from our Snowflake, from our data warehouse, right? Then we need to interact with compute. Let's say I'm doing stuff on pick cloud provider of choice. I'm not going to give any of them mindshare currently. But we need to access that from our local workstation and figure out how our data warehouse interacts with that as well. Suddenly, if we have several steps, we require some sort of orchestration to happen there. Then, when we're running a whole bunch of stuff in parallel, for example, we definitely need to log and version everything that's happening and store them automatically. And that this, once again, is an iterative cycle where data scientists can develop and test and iterate, as I've written here, on all their projects as rapidly as possible. So that's really the goal of thinking about how to operationalize MLOps, essentially, okay? So the question remains, and we can talk a lot more about each of these points afterwards, but how can you start applying the stack in practice today, okay? So I want to ask a few questions to answer these questions. If you're considering a solution, I want you to ask, does the solution provide a delightful user experience for data scientists and machine learning engineers? That relationship is key as well, and something culturally we've seen, you know, work across several verticals. In some places, it's still pretty challenging thinking about division of labor in the space. I think we can look to the modern data stack and analytics, the analytics stack, for lessons on how best practices, tools, and division of labor can work in such a technical space. And that can inform the relationship between data scientists and machine learning engineers. But we need to ask that question. Does the solution provide a delightful user experience for data scientists and ML engineers? Then, does the solution provide first-class support for the rapid iterative development and frictionless A/B testing? Super key. Third, foundational question. Does the solution integrate with your existing infrastructure, in particular, to the foundational data, compute, and orchestration layers? Okay, so these are all foundational and key concerns you need to be thinking about when adopting any new technologies for your ML stack. And there are a bunch out there, right? So as I've said, I work on Metaflow at Out of Bounds. And maybe I should say a bit more of that. So I'm head of DevRel, developer relations and community at Out of Bounds, where we're trying to build software and products that help with all the concerns that I've mentioned today. And Metaflow is the main open source framework we're working on currently, but we have a few other things in the pipeline that I'm very excited about. But of course, there's also Vertex AI, there's SageMaker, there's Azure Machine Learning Studio. All of these are definitely worth looking into, right? To ground this somewhat abstract conversation in kind of practical reality and code, I thought to just give an example of Metaflow with some of these concerns. So essentially, what the way we encourage data scientists to work is to write the Python code that they know and love, right? And so you can take your notebook code and refactor it as workflows with a idiomatic Pythonic, user-friendly syntax, which you can see here, and then you'll save this as myflow.py and run it as as such. This is a very basic example where we just have a start step where we import pandas and a data frame and then end it. Okay. Then, of course, you need to do a lot more, right? So if you want to run 100 experiments concurrently, independent experiments at scale on using cloud-based infrastructure, the way you would do that with Metaflow is not so different to the previous example. You have your start step, you'll have an end step down the bottom, and you'll just use this quag for each in order to massively parallelize this training step. And as I mentioned before, you can assign, I could actually just assign a Kubernetes cluster using @Kubernetes here. What we're actually doing in this example is we're assigning the memory resources there. And when I execute the code from the command line, I'm then saying with Kubernetes for the entire thing. But let's say you only had one step which required something huge. Maybe you just send that step up as well. That's relatively straightforward. How we think about versioning, everything just gets versioned automatically. And you can see here, anything you assign to self, essentially, the metadata gets stored and it's easily accessible after the fact. And I'd be excited to chat about kind of the ins and outs of that and how you access these things. The cool thing there is that it actually helps you to build experiment trackers yourself as well. As I mentioned before, we really need tools for fast data access. So that's something we've worked on and integrate with most forms of data that you'll need as well. So those are just a few of the kind of ways we've thought about it in terms of writing code as kind of a practical example. Maybe I'll play this. This is an example of, I mentioned experiment trackers and visualization. We are deeply visual creatures. And so we've built some things called Metaflow cards, which allow any data scientist essentially to visualize what's happening throughout any of the flows that they write. So you can see, this is the image data of New York City taxi data set. You can actually see down the bottom there was the DAG. You've got all types of artifacts there. You can see whatever's happening now where changing the code slightly and executing it. Let's see what happens here. Right, so this is, we're clicking pretty quickly through this GUI, but the reason I wanted to freeze frame on this tells you all about where your computation's happening, how intensive it is. And then the other thing I wanted to show for anyone who's more interested in the machine learning side of things, it allows you pretty easily to generate whatever visualization, such as your ROC curve here. I may preempt a particular question. I said you can build your own experimentation trackers here. A lot of people already use experimentation trackers, such as Weights and Biases, or Comet, or Neptune, right? And I mentioned earlier that I think software needs to interoperate with kind of the most used tools out there. And for that reason, at Metaflow, we have integrations with explicit integrations with 2 out of 3 experiment trackers, and some ones which are easy to generate yourself relatively straightforwardly with the others as well. But I can't stress enough how important I think interoperability is at the moment. And we've seen how it has been. There's a question like, how many vendors do you want to speak to, really? Like, if you have 20 steps and you have someone different for each, is that type of interoperability worthwhile? And the answer may be no, but it depends how small N is, essentially. And I think in the analytics space, right, with tools such as dbt and Snowflake in the modern data stack, the interoperability there has come a long way. And I do think this is probably another point to make. I've used that space and a few others as analogies or tethers, but I do think when trying to figure out what on earth is happening in our space and to forge a path forward, looking at other spaces can be useful, and seeing where those analogies break down can also be useful. I'm gonna end on that note. If you're interested in this type of stuff, come and chat with me on our community Slack, which is right here, slack.outerbounds.co. Once again, I'd love to thank Jared and the whole team for hosting this great meetup, and thank Noam and Eco Health Alliance for sponsoring it. And thank you all for attending. And I'm looking forward to hearing your questions and chatting.
Thank you very much, Hugo. Let's see if a little round of golf clap or emoji claps, actually, since we're in emoji land. No one knows if you're golf clapping. They need to make a golf clap emoji. Then the world will be complete.
That is the best idea you've ever had, I think.
Thank you. I agree. Yes. So everyone, I'll give some chances to ask some questions. A few already, and you sort of talked about it, but talk about all these different stacks and everything. How do you string them together? Is that Metaflow that's stringing them together? Is there one thing that does it all yet? Or are you still relying on different things?
Yeah, I do use Metaflow to string it together, and that's the way I would suggest doing it. There are some other tools, but I'll actually, what I'm going to do, I need to get this right. I want to just share my screen again and show you something. It's a schematic which I think will help think through this. And I will actually share this in Slack as well. This is actually something I published recently about how thinking about joining MLOps with DataOps, essentially how the modern data stack can be combined with the machine learning stack. Can you see my screen?
Yep.
So you can check out this more generally. But one way to think about, I mean, this is one project we've worked on where Metaflow essentially provides the backbone for the rest of the code. And when you want to transform your data, you can access DBT directly from it because it's all Python, right? You can access Snowflake, Comet for your experiment trackers, Reckless for testing the actual recommendation system, and then deploying it to SageMaker. Now, the reason I wanted to show this particular example is because Jacopo, our collaborator who worked on this, you can see his schematic of it, actually has all the code here. I've just posted that in Slack as well to show how, with Metaflow or in any other similar tool, you can actually do this type of thing. So I think that's the way I'd suggest doing it. In all honesty, a lot of places I've seen hand roll how to do it internally, right? So that's essentially, as I said, a lot of this is pattern recognition. So seeing how people hand roll things internally and then providing frameworks which allow people to do this is key. But the short answer is yes, Metaflow's the best solution.
So it seems like Metaflow is like a nice DAG, and we always like DAGs here. How do you get it to run on a schedule, right? You want it to run every day, every week, every month, every year, or different cadences. Is that something built into Metaflow? Is that something you need to schedule? Like, let's say you don't want that big machine sitting there all week long. You just want to use it for Sunday night. Like, how do you handle all that?
Yeah, exactly. So we've got integrations with all types of cloud providers to allow you to schedule things pretty precisely doing it. But yeah, it is baked into Metaflow to allow you to schedule yourself anywhere also. And I'll actually, what I'll do is it okay if I just paste things into Slack that answer these questions as well?
Please do.
Provide technical. So this is literally a page on how to schedule Metaflow flows.
Cool. We might have to have you come do a whole workshop in Metaflow one day.
That would be really fun, man. And because I just gave one at SciPy. And so I've given this 4-hour workshop actually on full stack data science with Metaflow, but I've given it twice before virtually at ODSC, but this is the first time I did it in a room of 100 people.
Feels nice, right?
It was amazing. And so what I've just linked to as well actually shows you, I really like this. As I mentioned, we work with a lot of decorators, but we do have an at-schedule decorator to run on step functions if you want to do that, which pretty much requires you to do not much else.
Good. Then I guess sticking in Metaflow, I know Metaflow supports R through Reticulate. What about other languages? That's using R to call Metaflow, but how do you use R or Julia or SQL inside Metaflow steps? Like how do you recreate the R environment or a Julia REPL? What do you do?
That's a good question. We did have an R story previously, which is on the side currently. So we actually don't support R
all right.
Yeah. There are ways to do it, but there's definitely a lot more support for Python.
Oh, yep. What about having to make a custom C++ or Julia or name it, Rust or SQL? Do you have steps for that, or is it just everything's in Python?
Everything's Pythonic currently.
Okay.
Yeah.
Cool. Then let's talk about, you mentioned DBT a few times. I know that's so hot right now. Can you tell us a little bit? I know it's not tangential to your talk, but can you tell us a little bit about DBT?
Yeah, I think what DBT has done in terms of building a community and a tool and a suite of best practices to allow analytics and data transformation to take place is really strong. And it's allowed people to communicate across the entire community as well, which I think it isn't only about the tool, right? It's about creating a class. We talk about like DBT analytics engineers and that type of stuff, right? So it's actually created a class in a community. So I think the way it's made it easy, ergonomic, and elegant for people to do their transformations has changed the space. And I think a tool like that, or a set of tools in the machine learning space, would actually bring us a long way. It's not clear that the patterns are as similar though, or that maybe a set of different tools, right?
What makes DBT so much nicer than writing pandas code or dplyr code or other stuff? What makes it so much more, like you said, it more, I forget the word you use, but so much nicer? Why do you like it?
Have you ever tried to write pandas code?
No, I write a lot of dplyr, not pandas.
That's a good question. I think so I've never used dplyr to deal with large amounts of data, so I can't really speak to that. But the way I can, we all can get DBT interacting with our really large scale databases with Snowflake, all of these types of things. I'm not certain how that would work in dplyr. I'd actually ask you that. Are there affordances of DBT with respect to that maybe dplyr lags on?
I don't know enough about DBT. Part of the reason that was my question actually to you, trying to figure out about DBT. But I know, so dplyr could work on Snowflake. It translates your dplyr commands to Snowflake commands. It can work on Parquet files. It translates it to Arrow. It can work on Postgres because it translates it to SQL. So it just works in backend agnostic. So I guess is it the fact that DBT works on large data is like the coding style is nicer than pandas? Because honestly, I have little experience with pandas. I know it's more like base R, but what makes it nicer than that? It's just a friendlier language.
Yeah, I've definitely found it friendly, but I'd half joke about pandas.
Wes is not watching, so it's okay.
No, and pandas is an incredible.
Yeah.
I think we'd all agree that it can be bloated in some directions, but that's a minor nit in a tool that's essentially had entire industries built upon it as well, right?
Yep.
Yeah, no, it's a good question. I'd need to figure out a bit more about what's happening with dplyr now to answer that well. I do think on top of the tool, the shared common language, the framework, the community it's built, and the best practices is a huge part of it also.
Okay.
Yeah.
Cool. There's a comment more than a question here, but Will Landau, who wrote the targets package in R, which is essentially like make for R, is working with Metaflow to somehow combine them somehow. So I guess, do you have any news, or is this a secret to you even?
That's actually a secret to me. So I'm excited to hear more.
Okay, so we'll have to wait. In fact, so Will spoke at the the meetup over a year ago. So maybe he's overdue. We'll have to wrangle him again and get him to divulge any secrets he has. Or otherwise, everyone's just go hit Will on Twitter and ask him, what's going on? What's going on? Just to drag it out of him.
We should all do that.
What tools do you like in the data versioning space and why?
Wow. Data versioning. Well, no, I think Metaflow is the way to do this. In all honesty,
you got to show your work.
What's that?
Yeah, remember math teachers tell you show your work, give us your reasoning. Why is that better than Pachyderm? Why is that better? We had a talk a few months ago about, actually it was Noam. He gave a talk about another database that does data versioning. So what makes Metaflow versus Pachyderm versus this other one whose name I'm forgetting? Why Metaflow?
Yeah, so I think because for me, Metaflow, the versioning aspect of it you get for free with everything else. I don't necessarily see why I'd introduce a new tool into my framework, right? So as I showed before, one of the reasons I'm so excited about, or I was initially very excited about Metaflow is there's a question around experimentation trackers. And I think they're incredibly interesting. And they come down to some of the versioning story we need to tell as well, right? In that experiment trackers solve a very important concern. My personal take is that it's a downstream concern of the versioning question, essentially. If you're able to version models, data, code, all of these things well, you can then build experiment trackers on top of that. But you need to have logged absolutely everything. And the reason I'm telling the story in this roundabout way is because I was excited when I heard with Metaflow, you actually get that for free on top of everything else. And then you can build your experiment trackers on top of it.
Okay. All right. And the company name I couldn't think of was Dolt. They're the one that has another version database.
Oh, I don't know Dolt.
Yeah. So Noam gave a talk about it in May. So you can go to nyhackguard.org and check out the video.
Awesome.
Yeah. Someone's asking, what's your thoughts on AIM? It's an experiment tracker, aimstack.io. That's in the.
I actually don't know about it. So let's look at it in real time.
Yeah, share your screen, pull it up. Let's hope that's a good link.
I mean, the big problem, of course, is that all websites say the same things all the time now, right?
Mm-hmm. Yep.
So let's see what we can see. It's easy to use. Great. I love that. It's supercharged. Not sure what that means. It's open source. I like that, although that can mean different things. It's an ML experiment tracker, logs your training runs, very good, enables a beautiful UI to compare them and an API to query them programmatically. All those things sound fantastic. I also like this, the visuals look great. So what is their business model if they're open source? I'm actually asking this when I try to, yeah, interesting. So it's not clear. Without having used it at all, it's not clear to me whether it's a useful tool, but it looks nice. And I actually like the fact that I've already got strong signals of what it interoperates with as well, which, as you know, is a really important concern of mine and all of ours. So promising at the start. I wonder. No, I'm not going to look at the GitHub stars. That's because I'm not going to legitimate that type of behavior.
Mm-hmm. Fair enough. I see a few more people are typing. Until then, I'm going to make you talk to us about some Metaflow alternatives. Why not Airflow? Why not all these other ones, Luigi? Why not this and that? I'm not sure Luigi's still a thing.
Yeah, why not Starflow? Any other thing from Starflow? Mm-hmm. So Airflow's a great orchestrator, right? Mm-hmm. But as far as I can tell, it's definitely far more useful for data engineers than data scientists trying to iterate very rapidly and go from prototype to production. So one affordance that I think is very important that Metaflow has that Airflow doesn't is the ability to rapidly parallelize training and train 1,000 models at once if you want, and build that into your DAG, which isn't an affordance that Airflow has. It may at some point. So I'm not saying that, you know, the wonderful people at Astronomer won't get to that. I do think one of the biggest selling points for Metaflow from a lot of users that I've spoken to is the ability to write only Python and SQL code, essentially, when you need to write your SQL, right? The fact that you don't need to use any SDK or learn a whole bunch of new stuff, writing classes in idiomatic Python. And that's, I mean, that sounds nice, right? But let's think about what it means in practice, right? It means if it's you save an hour a day or something like that, that's incredibly valuable to a company, but it means you're not banging your head against the wall, right? All the time. And I think in terms of, once again, tightening that iteration loop between prototype and production, the ability to write something in your own language is incredibly important.
Mm-hmm.
And that's, I mean, we can talk about the other flows. We can talk about, you know, Kubeflow, for example, right? Which even for, you know, really technical people, like getting Kubeflow up and running, like no data scientist should ever have to do that, as far as I'm concerned. Perhaps if you're working data science consulting and you actually need to be really full stack in some way, but maybe you need an ML engineer on your team as well, to be honest, at some point.
That's why we are hiring Linux admins who are in the role. Yep.
Fantastic.
Yep.
Yeah, so I think that's that. And on top of that, the decorator based nature of it, to be able to change your steps and send things to different places, access different types of data whenever you want, is definitely a value proposition I've heard a lot of data scientists talk about.
Cool. And while you were describing this to us, Noam chimed in. All websites are the same thing. He just sent another question, Aqueduct HQ. Let's check that out. Let's see what's in there.
So, and Noam's question actually was, how do you tell the difference? And it's actually incredibly tough. I actually think one of the best ways is to look at this. Most companies are on Slack or Discord these days, to go in there. But look, you can get on a call with a sales rep and still not know the difference after that call, right? So the struggle is real. Huh. I like the name Aqueduct.
They have decorators. They connect to similar processes.
Fascinating. That's I mean, yeah, this looks like an interesting project. Absolutely. I will definitely join their Slack channel. So let me say, I think they have around 300 GitHub stars, which,
but we're not going to legitimize that, you said.
Well, so let me actually be very explicit. I'm not going to legitimize using GitHub stars as a proxy for usage. I will use it as a proxy for awareness. I actually think it is a relatively good proxy for awareness, but not for usage, I think.
Okay.
That isn't to say this is this tool looks very interesting. Wonder who yeah, cool. Well, I'm definitely going to check it out, at least when we're doing our next SWOT analysis.
Nice. So then we have another question. Two parts, because she asked and she clarified. So I, being Joyce, I teach data science students, so I think a lot about if what I'm teaching them will prepare them well for industry. What pain points do you see new data scientists encountering when they begin dealing with ML in the real world? To put another way, it seems that a lot of the stacks you're describing aren't conceptually different from what students are doing in our studio, just more powerful. So welcoming any thoughts. If you need to read, if it's easier for you to read than here, it's in Slack from Joyce.
Yeah, I am reading it. I wonder, how do you think about this, Jared? Because I do feel like the stacks I described are quite different from RStudio.
Different from RStudio, but like almost everything here we could do with targets, let's say, right? Targets, it builds a DAG automatically. And the nice thing I like about targets is all you have to do is just a downstream step applies a function to an upstream step, and it automatically draws a DAG. And it can automatically, I can say, okay, this step pulls the data from the database, this step fits a model, this step publishes the result somewhere. So to me, targets does at least all of the DAG stuff. It doesn't necessarily do the, experiment recording or the scheduler. You can run it, you can or put a cron job on it. But to me, at least to me, my view is a lot of the stuff, it's all about the DAG. And targets is another DAG written in R code instead of written in Python code. Obviously, MLflow or Metaflow does more than just the DAG, but that seemed to me, when I'm looking at these things, it seems like that's the bulk. I'm guessing that's the voice is coming on here too.
I understand that. And maybe I can then, not knowing enough about targets, I can't speak to targets. I can speak to RStudio in that I think depending what you're doing in academia and research, I do think a lot of the time, as I said, the scale of operations will be significantly larger or can be significantly larger in business applications, particularly not only data, but in models. The orchestration is absolutely key, and that speaks to the DAGs. The versioning story as well. So robust versioning for data, model, and code. And then the most significant thing perhaps is integrating these ML-powered apps into like business logic and business systems, right? So so maybe this will help Joyce. If I want to like run 100 models, experiment 100 models in parallel while I've got one in production, if I have one that is performing better than one in production, how do I switch it out without, breaking absolutely everything in the business system, right? So I think those four in particular: scale of operations, orchestration, versioning, and embedded in business systems. Those are the
I'll give you the one of those works, like scale, like targets, nice thing, not to go competing against Metaflow, but like targets for your edification, you can actually run it on a cluster and different steps run different steps. Look at targets. I think you're gonna like it. It's very cool. I think you should add that to your SWOT analysis. I think you'll really enjoy looking at targets.
Yeah, I'm really excited to check it out, man.
Yeah. And if Will is indeed working on somehow integrating targets of Metaflow, I think that's going to be a really nice move.
That would be very cool.
Yeah.
And just to be clear, like my intention isn't necessarily to convert everyone to Metaflow, but to start this conversation so that you all convert to Metaflow.
Yeah. Cool. I think that's everything. There is a comment from Patrick just talking about the decorator design pattern. That's common. Dagster, Prefect, Metaflow.
Yeah, absolutely. Yeah, I didn't mean to suggest that was unique to.
Oh, I don't think anyone did. I think you should, because we're talking about, because like Noam found Aqueduct that used decorators. Some decorators are being used all over the place. And decorators is a really cool feature that makes life easier. I did see someone try to implement them in R, but it hasn't taken off nearly the same way it has in Python. In Python, decorators have really been a huge deal.
Yeah, absolutely.
Yeah. Beyond just the flows, it's useful for so many things outside of that. Actually, last question. Can you tell us, for the people who don't know here, tell us what a decorator is, if that's sort of in your wheelhouse?
Yeah. I think the best way to describe it is a function that acts on another function. So it changes the behavior of a function. So the example here, or the example I gave, would be if you don't decorate it with @Kubernetes, it just runs it locally. Whereas if you put the @Kubernetes decorator on it, it changes where that code actually executes.
That's really cool.
Yeah.
So does it essentially create a new function that calls your function as part of it? Is that what's like the
I think that's how it's implemented in Metaflow and in most places. I would want to just I want to get this right.
Mm-hmm. While he is researching, I'll tell everyone, if you have one last minute question, we're going to wrap up soon. You want to slide in one at the last deadline, like Indiana Jones grabbing his fedora after the door's closing, now's your chance.
Yeah, so a design pattern in Python that allows anyone to add new functionality to an existing function or object without modifying the structure of the initial one.
So I'm going to guess, having not used it much, what happens is when you put that in and you source your Python script, a parser has to go through and it finds this and it grabs a function underneath it and then wraps it and exposes it as another function without you really having to do anything.
Yeah, for the most part.
Cool. Does it work in notebooks?
Yeah.
Okay. Very cool. So I know they're the decorators on R had to only be worked in like scripts you sourced. It didn't work interactively. So the fact that these work inside notebooks is really, really cool.
Interesting.
That's a really nice touch. Okay, cool. So here's what I'm gonna do. I'm gonna make the closing announcement, just a reminder about some things I announced. If there happens to be another question that sneaks in, we'll allow one, only one. If there's more than one, please go into the monthly meetup chat and ask Hugo there. If we were in person, I say, let's go to the bar afterwards. You could ask Hugo there if you were in person also. If you're virtual though, that wouldn't have helped you. So please do chime in here if you have questions. So just a reminder to everybody, we are looking for a meetup space so we can hold these beautiful in-person virtual meetups again. If your company or your agency or your office or wherever you have space, your university, would like to give us some space somewhere in the city, let us know. And folks, we're always going to do this both virtual and in person. In fact, the last 2 months we did it in person, we used YouTube Live as our simulcast. Let me know how you think about that. Did people like that? Do you prefer Zoom? Do you like YouTube Live? Do you like some other platform? We are open to experimenting. YouTube Live worked, I think. People attended it, and it worked for me technologically. I was able to hook my camera up to it. But let me know, folks, if you didn't like it for some reason, or if you had trouble signing up or whatever. Let me know, and let me know if you have space. Very important. The NYR videos from this past June are up at rstats.ai, so go check those out. 20-some talks. It was a really fun conference, again, both in person and virtual. And likewise, December 1st through 2nd, well, November 30th through December 2nd. It's so hard to combine 2 months. We have R in government, where it's R and friends in government. Maybe there'll even be a Metaflow talk or a workshop. We'll have to discuss Hugo, see if he's allowed back in the country by then. Yeah. So no, Hugo's going to have to eventually go back to his homeland at some point. Maybe he'll come back here for this.
It's did you say October?
No, November 30th through December 2nd.
That's possible.
The one in October is Shiny in Production in Newcastle. That should be a fun time. And then Hugo mentioned ODSC. For those of you that don't know, ODSC is a pretty cool conference, pretty large, held around the world. The next one is coming up in November, I want to say, in California. I might be wrong on the month. I'm pretty sure it's November. I'm speaking there, but I don't remember the month or when I'm supposed to be there. But yeah, so ODSC is coming up. That's another cool conference that, friends of the meetup that we really like. So remember, rStats.ai for meetup, the conference videos, NYHackR for meetups from videos from this meetup, are in government coming up in December, Shiny Production coming up in October, ODSC, I believe in November. Don't quote me on that. I get a better book my flight. And jobs. If you're looking to hire, post it in the jobs posting channel. All right. So thank you everyone for attending. Thank you, Hugo, for your presentation, answering all of our questions. That was terrific. Folks, you want to see Hugo here again, asking a lot of questions in meetup, so many questions that he has to come present on something to tell us everything. We'll get him here anyway. We'll find some other way to get him back here anyway.
I'll definitely ask as many questions as possible, and I'll be on the Slack in the next couple of days and just reach out.
All right, wonderful. Well, everyone, let's have a nice emoji clap for Hugo. Thank you very much for being here. I had a really great time. Hope everyone else did too.
Thanks, Jared. Thanks, everyone.
Bye.